Welcome, friends. My name is Vijay Kumar. I'm the Dean of Penn Engineering, and I am your host of Penn Engineering's Innovation and Impact podcast. Our podcast shares insights from some of the leading experts from around the world who are Penn faculty and researchers, people who are bringing to you the latest breakthroughs and innovations in science, technology, and medicine. Today, we're going to talk about leveraging engineering and AI to transform human health and beyond. We've covered a lot of topics over the past year on this podcast regarding AI. Today, we're going to delve deeper into how engineering and AI can transform human health. Indeed, the fields of chemical engineering, artificial intelligence, and biochemistry are all very different. And this project, remarkably, brings these diverse fields together. But at Penn, such deeply interdisciplinary thinking is part of our DNA. It was ingrained in our culture long before interdisciplinarity became a buzzword. At Penn, we know how to nucleate innovative education and research projects across disciplines. And we have the cross-cultural ties to nurture and sustain these projects. Today on this podcast, I'm excited to highlight some of Penn's interdisciplinary work by bringing together three researchers to talk about a project they're leading to produce the next generation of groundbreaking RNA-based technologies using AI. Their project is called the AI RNA BioFoundry, or AIRFoundry for short. Welcome to our podcast.
Thank you.
I'm going to ask the first question of Daeyeon Lee. I would like to give the audience a rough overview, a high-level overview of the project.
Well, thank you, Vijay, first of all, for inviting us. So we have all witnessed the transformative impact that RNA can have in human health. So by encapsulating these RNA molecules in these tiny little fatty particles called lipid nanoparticles, mRNA vaccine has saved millions of lives. So we may think that this success was an overnight success. However, it took years and years of failures, iterations, to get to this point. So we have to ask ourselves, why did it take so long for mRNA to have such a big impact? Well, there are many challenges. RNAs are very fragile. Optimizing the sequence of RNA is always not trivial. And making high-quality RNA is hard. RNAs are, because of their fragility, they have to be encapsulated in these things called lipid nanoparticles. Lipid nanoparticles determine where RNA ends up in our body. For each RNA, you have to have a new lipid nanoparticle, but we don't really know how to design these things. Also, because the field is expanding so quickly, for a newcomer, it's very difficult to come and understand where to start when they want to start using RNA. So there's this huge barrier for people to enter if they were not already in the sphere of RNA technology. So the vision of AIRFoundry is to really facilitate and come up with a new way to design, deliver RNA molecules. So we're going to do this by creating an open access platform where people can have access to new knowledge as well as materials. And we're going to do this by using AI to augment human knowledge. AI will curate the knowledge in a way that newcomers or those who already have expertise in this field can come and design experiments and also get recommendations about the materials. AIRFoundry will also have physical facilities that will provide high-quality RNA and LNP materials such that users can now take those materials to their own lab, test their ideas, perform experiments, and then they'll come back to the AIRFoundry with their results, such that the results gets fed into the AI, and AI now will become more powerful, and it will also be able to make more accurate predictions about experiments and make better recommendations. So overall, our goal is to democratize the RNA technologies for those who already are in the sphere, but as well as those who have not been able to use RNA technology, and use the technology to come up with new solutions in health and beyond, in all fields of biosciences, whether it's in agriculture, environment, or sustainability. And most of all, we are very excited about training a new cadre of students and postdocs who will become the leaders of this new field, equipped with knowledge in AI as well as RNA science.
Thank you, Daeyeon. Very exciting. I think of you as a chemical engineer. So when you say chemicals, biomaterials, or lipid nanoparticles, I get that. But this project goes well beyond that. So I'm curious if you can say a little bit about how the project got started, how you got introduced to Kathy and Zach. Tell us about the sausage, the making of the project.
Very good. So let me go back to your opening comment. You said something about Penn. Interdisciplinary is in our DNA. We like to say interdisciplinary is in our RNA. So we were already, there were smaller scale collaborations that were going on campus, and many of those collaborations centered on enhancing the delivery of RNAs, making better LNPs, and also creating platforms that can make large quantities of these LNPs. Now, last year, Dave Meany, our associate dean, actually found this opportunity from NSF about biofoundry. And I got together with a few of our colleagues, and we quickly realized that this could be a game changer. At that point, we decided to think about how we can really widen this platform to those who are not in the spheres of RNA technology. And we thought that in order to do that, we had to bring in AI component. AI was, clearly it was changing the world. And by bringing AI, which was changing the world, and RNA that saved millions of lives, we knew that there was an opportunity to really make a transformative impact in all domains of bioscience. At the time, we didn't have any AI, expert on the team, and that's how I connected with Zach at the time. I believe I emailed Zach, and we met the same day to discuss the potential impact of this collaboration. Also, in order to make RNAs and make them stable and also be able to introduce different types of modification, it's important to have somebody who knows how to design and engineer enzyme. And fortunate for us, Kathy was on campus. I emailed Kathy, and we had wonderful discussions, and she was very excited to be on this team. So all these different team members, we were able to find, many of them on our Penn campus, and we were able to put together the team.
Terrific. Zach, maybe I can ask you the same question that I asked Daeyeon. But before I ask that question, would you give the audience an overview of your background? And then perhaps I'll just ask that question. How did you get involved with this project, and what excited you about this project?
Thanks, Vijay. So my background is really in using AI and data integration techniques to try to give better answers to people who have questions, especially questions around, really getting an understanding of a domain or a problem where we actually provide evidence, not just the answer yes, no. And I worked on a variety of different applications because as a computer scientist, what you're trying to do is see lots of individual problems and come up with general solutions that can be templates that can be modified in small ways to solve a whole swathe of different problems that other people will come up with. So working with folks across campus who have real problems is a great way of finding these kinds of things. Every problem that exists in biology or medicine probably has thousands of similar things that are in fact easier in the web or business or other applications. The thing about most of the collaborations I've had in the past with neuroscientists or geneticists has been these are in domains where people kind of know what they're trying to do, and they kind of understand at least the basics of the data and the domain. What made the AIRFoundry and the RNA space really exciting is we're actually at the very frontier of even figuring out what we can do with RNA, who the users are, what questions they might have, how they might use both RNA and AI. So we have this really intriguing opportunity to kind of grow the user base while we're defining these solutions. The big thing that we have today that maybe wasn't available 3 years ago is all sorts of technologies from large language models and GPT and so on give us a way of taking general knowledge learned from the entire internet and then fine-tuning it or adapting it to new domains. So there's an exciting tool set to use to this completely leading-edge frontier of discovery. So that's what really got us as computer scientists excited.
Interesting that you say that. I look at large language models, GPT, and so on, and then I ask, how does it benefit human life, society? What's the impact? But maybe this is the thing that we're all looking for, a way to use generative AI to leverage that to develop the next generation of therapeutics.
I think that there's a huge amount of enthusiasm for trying to use these AI tools, including not just language models, but multimodal models that can take into account video and images and even other kinds of information, and use them to point people at the most promising starting points for new discoveries. And that also is a big piece of what we're trying to do here. The hope is that if we can build tools that are useful for RNA, maybe that also provides a template for general scientific discovery and innovation.
Yeah, truly exciting. Kathy, same question for you. Daeyeon just described how he connected with you and how you responded. But I'm curious if, again, for the perspective of the audience, if you can tell us a little bit about your background. And then I'm curious, what about this project excited you and where do you see the innovation going forward?
Yeah, thanks, Vijay. So my training background is in RNA biochemistry, in enzymology. So we study how RNA works with enzymes in those RNA enzyme complexes, and RNA work with the protein in those RNA protein complexes in gene regulation. And when they go awry, how that link to human diseases. So I'm an RNA biochemist doing fundamental science, so I love what I do. I'm very passionate about what I do, but it's our mechanistic level of understanding when things goes awry, why it lead to certain types of diseases. But this biofoundry is really lead me to think that how to use the knowledge, the mechanism that we learned in this processes to get like a direct applications to cure those diseases, at least to take us a step like further. So that when Daeyeon had this absolutely stunning opportunities and contacted me to, this is the thing that we have been, as a fundamental scientist, that we have been trying to do, but lack of the knowledge or lack of the venue to really push it forward. So it's a very natural but great opportunity to take it one step further. So as you said earlier, that Penn is a very interdisciplinary, is highly collaborative. But even for that spirit, I think this project is very unique because it nucleated a lot of opportunities to bring together scientists from a different background, like a computational biologist, fundamental science, and also engineers to really push the fundamental level of understanding, which we actually accumulated for years, all those knowledge to push it to the frontier, how to use that knowledge to benefit the entire field. So it's absolutely amazing for us.
I was just hearing you talk. It just reminds me that it's not just about interdisciplinarity, but also the way we create avenues for fundamental work to find its way into applied domains, which clearly this project is doing.
Yeah.
Just pressing you further. So, what other applications do you see besides the specific ones that you're targeting? I mean, this is obviously you study mechanisms. These are powerful tools we're bringing together. There's got to be more to this, right, than this particular project.
Yeah, many. So it's going much beyond the medicine and the healthcare, although I think medicine and the healthcare, the potential is huge. We can do it for many years, but it's definitely going beyond that. For instance, it will help like agriculture or environmental science, and I'll give you some like more specific examples. So this using the RNA technology, we can to improve weed management. We can improve ecosystem. We can use the RNA technology to enhance the properties, enzymatic activities of a certain important enzyme in microorganism to help them to digest plastics, heavy metals better. This is going much beyond to, I would say, probably to say that it's going to change the way we are thinking about science to almost every discipline you can thinking about. And one unique opportunity I like to mention is because of the interdisciplinaries already have. So we think it's going to nucleate many new field that the RNA technology is going to help and shine light on.
Very good. Thank you very much. Zach, maybe I can ask you the next question. As an engineer, as a computer scientist, you think a lot about innovation. But as we've seen, oftentimes innovation has a way of going awry. So do you worry that this project where you make these very powerful biomolecules could be hijacked to make things that you did not intend to?
So this is a great question, Vijay. I think we've been trained as computer scientists, and especially as computer scientists working on AI, to these days really have an appreciation that, yes, we start off trying to solve these interesting problems, and these interesting solutions we come up with might have an upside, but there can also be risks and downsides. What's interesting about AI for RNA is some of the traditional things that AI people think about, like what happens if we have a biased set of data that the AI learns from, are probably not that important in the scheme of RNA, because people are taking the results of our AI and actually validating them in the real world. But instead, the risks are mostly that people might be trying to target, engineering of pathogens, or developing solutions that have some kind of deliberate downside, or that inadvertently, end up causing some kind of biological risk. So I think the piece that we're really trying to put a lot of deep thought into is how we can mitigate that by restricting, for instance, the solutions that the AI tools will generate, making sure that, for instance, they can't target pathogens and so on. Fortunately, we have both a bunch of experience from the RNA engineering that Drew Weissman's lab has already been doing, and we have actually one of the top groups in the world with Penn's Asset Center for trying to understand how to limit AI models to produce trustworthy and reliable and safe solutions. So our hope is that we can put these different components together and make sure that indeed we keep the solutions from our AI in a space that's safe and leads to positive outcomes while really, really mitigating the risks.
So no James Bond movies will be made on this theme.
We have
But just to press you on that, I've found, at least through my limited experience, that it's really hard to explain some of the designs that you get from generative AI. So is it part of the goal, and maybe I can ask you this question too, Daeyeon, that you want your solutions to be completely understandable, maybe with the mechanistic understanding that Kathy talks about? Is that a goal of the project?
So right now, the way that we're thinking about this, there are sort of two major components to the AI. One is, you could think of it as a generative AI tool that is a maybe super duper version of ChatGPT. Scientists can be talking about, some target application, an organism, and their goals. And what we will try to do is take all the evidence in the published literature and past data sets and past experiments and domain knowledge and so on, and try to give them starting points for discovery. So for that, there will be a lot of, if you will, explanations, justification, pointers to sources, and so on. Then there's a second component, which will take this starter RNA and explore different variations on it that might be more suitable for the application. That part, I think, is going to be much harder for us to exactly explain why, but I think that the correspondence to the starter RNA will be fairly intuitive. And so at least today, that's how we're thinking about the problem. Daeyeon and Kathy may be able to give further insights on this.
So we've talked a lot about how RNA can be used for solutions for challenging problems, but what we also hope is that by having this facility that can provide high quality materials of RNA and LNPs, it will provide researchers with opportunity to address fundamental questions as well. It's very difficult for a graduate student right now to have access to hundreds of RNAs to do what they want to do in their lab. Our RNA BioFoundry will be able to provide those materials to the student such that they can now start addressing very, very fundamental questions so that we can have even deeper knowledge into this area. So that's one way I like to address your question.
Very good, very. Do you want to add to that?
Yeah, I just want to add a little bit. That's all great. And so I think the BioFoundry can help people from different angles, different interests, and also different knowledge base about RNA. Like for students or people outside of RNA, the current outside of RNA areas, we can provide how to guide them to really think about using RNA and with the high quality materials and the design. And for people targeting RNA expert but try to target very challenging problems such as I will use cancer as one example. It's just a huge domain with the sequence of variables, different combinations of modifications, different properties, and the AI is absolutely gonna provide a lot of valuable information there. And the goal in the RNA Foundry is to integrate the AI and the benchwork to train and teach each other's, and AI helps us what are the leading molecules to be tested, and we kind of provide the information back to further telling the AI, oh yeah, you're doing it on the right direction, or kind of teaching each other. And let's see, time will tell how this model is gonna work in the future. Yeah,
I love that comment. In some ways, I think it almost sounds like the way we'll be explaining what the AI does is to go back to the bench science and actually validate and understand the bigger picture, right? So it's not necessarily we even have to have the explanation at the start. Maybe we find it out after.
Great. So you said time will tell. So let me segue from that and ask you to project forward 5-10 years from now. Where do you think the project will go? And more importantly, in your field, how do you define success?
Okay, great question. Speaking of the future, I like that. So I think maybe three, a few important measures. First, I would think that our success is to really inspire a lot of people who do not think about RNA in the past, but really start to use the Foundry as a resources to bring RNA as a component into their own research. Let's nucleate a new interdisciplinary field. Let's see which field that we nucleated through the BioFoundry. As I think the second thing is to really deepen our understanding, to show the power of the combination of AI and benchwork, and also deepen the understanding not only at the mechanistic point and how much we can push really to practical application, direct applications to help people, help patients. And I will end with my last point is I think an important thing about the current fields is to train the next generation scientists to really equip them from the beginning that the computation biologist, AI, and the importance of the benchwork, and all together with the tools that they can really drive the field further. Be honest.
Thank you. Zach, same question to you. Project forward, see how is this field going to develop? And in your specific discipline, what do you think the breakthroughs might be 5-10 years from now?
I think with regards to AI and computer science, the real breakthroughs that we would love to see happen out of this are we come up with tools that really help scientists whittle down their options and accelerate the process of targeted discovery, right? If we could actually have AI tools that make RNA engineering, a field of its own, I think that's a good measure of the promise and the impact. And of course, the hope is if we can do this for RNA, then in turn, AI for accelerating scientific discovery becomes a big thing. The goal is always that we need human creativity and expertise in all of these problems. But if the AI can help guide toward the promising experiments that have successful outcomes and not the many, many failures that nobody can even talk about and see, I think that could make a huge difference in overall progress across all of academia and engineering and medicine, and not just AI. But of course, it would be a huge step forward to have AI tools that can do this.
I love that vision. I think the synergy between AI and sort of the process of scientific discovery and innovation is huge. And again, I go back to my comments about large language models, and what people are using right now is to basically have fun and burn up a lot of GPU time. But yes, same question for you. So where do you see this 5-10 years from now, and how do you define success in this project?
I think Kathy and Zach really summarized our thoughts very well. I think when I open my toolbox, I see common tools there: hammer, wrench, screws, right? Screwdrivers. I hope that RNA can become a tool in everyone's toolbox. And I think the most exciting opportunity is that RNA can solve problems that are unknown to us right now. In 5-10 years from now, there will be new problems that we are not anticipating. And if people are using RNA as part of their solution, I think that will be a huge sign of our success.
That's a great, inspiring story. How would you advise young scientists, young engineers, as they get started out? How should they think about this discipline, and how can they equip themselves with the tools, techniques, the methodologies to be successful in this field?
Sure. Well, this is my opinion. We talk a lot about interdisciplinary research, which is important to make new impact, big impact in various areas. In order to become a powerful player in interdisciplinary research, I believe that it's important for you to become an expert in an area first. That way, you can meaningfully contribute to the interdisciplinary research. For those of you students who are very interested in what we are doing, whether you're a mechanical engineer, chemist, or you're interested in energy policy, there are many ways to interact with us. Come to our website. It's airfoundry.org. We are also having an event in collaboration with the RNA Institute. It's called RNA Day at Penn. It will be on April 1st and 2nd, and there will be events for students of all ages and levels. And we hope that we can see many of you there.
Awesome. April is also AI month for us, so there's a good synergy there.
Excellent.
Same question to you, Kathy, and I was intrigued by what you said about combining bench methodology science with now computational methods, and the average RNA chemist doesn't think about these things, right? So how would you advise young students in your discipline?
I really like the comment, but I will add a comment on your comment. I think it's like a relatively older RNA biochemist would not think that way. I think the young generation is already doing really great, like combining these two areas. We would like to further push it a little further, like by combining not only bioinformatics, but actually combining AI to this component with the bench work. But what I would say, I completely agree with the Daeyeon side. You need to be like a passionate and be an expert in one particular area, but keep a really open mind to absorb the good things and knowledge from things that could help your own area. And in terms of the biofoundry, I would say just the AI component, the bioinformatics and bench work. I think our course development need to catch up, really have the AI component into the course. But that's what we have been discussing and what we have been doing.
Mm-hmm. Zach, any comments about training for computer scientists? It seems like it's a tall order for them to understand, as Daeyeon said, the domain-specific issues in biochemistry and chemical engineering, for instance.
That's a great question. I think that I completely agree that a key part to all of this is to be an expert in one domain. The other key, I think, is to be always thinking about the connection between general solutions and specific problems, and to just sort of stay inquisitive about what is going on in tech, what is going on in the world. One of the things that I benefited from is, there's a wealth of talks on YouTube, seminars, and so on, that if you're genuinely interested in knowing a little bit about a lot of things, this is totally possible in today's world. So I would say that, in my mind, is a huge part of what it takes to be a successful modern academic, especially as an engineer. For specifically the AIRFoundry, I think we're going to be putting a good deal of effort into building different modules that bridge these different technologies, the different fields, the different backgrounds and mindsets. But a lot of that is really curating what's already out there. So folks who are interested can themselves find all of this stuff. Our job will be to kind of weave this together and make it more efficient to do so.
Daeyeon, Zach, and Kathy, thank you so much for spending time with us and sharing your insights. I'm certain that our listeners have learned a lot throughout our discussion. I want to thank our audience for joining us for Penn Engineering's Innovation Impact podcast series in this particular episode on leveraging engineering and AI to transform human health and beyond. Please subscribe to our Innovation and Impact podcast series on your favorite podcast platform and watch a video of this recording on Penn Engineering's YouTube channel. We will see you next time. Thank you.